Good evening and welcome to the Wallenpaupack InvenTeam Mid-Grant Technical Review. My name is Mandrick and I'm a member of the technical team. Tonight we will be showing you our progress and what we have learned so far. The InvenTeam initiative, created by the Lemelson MIT program, offers an unparalleled opportunity for high school students to cultivate their creativity and experience invention. InvenTeams are teams of high school students, teachers, and mentors that receive grants up to $10,000 each to invent technological solutions to real-world problems. Each InvenTeam chooses its own problem to solve. Lake Wallenpaupack has 52 miles of shoreline with 1,508 front lot properties. Of those, 1,291 are residential, 42 are commercial, and 175 are for community access. Each one of these lots has at least one dock, resulting in a minimum of 2,500 docks. AC electricity is not permitted on docks. Lighting on docks can be poor with only shore lights available. And so we have invented a lake waves generator.
Hi, my name is Adam Haig, and I'm also a member of the technical team. Our invention statement said that we have a generator that uses the movement of a boat dock to produce DC electricity through the Faraday effect to light an LED. This generator consists of a piston-type machine that generates electricity when the waves cause the dock to rise and fall. Once the pipe is attached to the dock with a ball and socket mounting bracket and will contain a coil of copper wire, just as this piece shows. The second pipe, mounted to the lake bed with a ball and socket joint on a weighted bracket, will contain a magnet, and the magnet will move through the coil in and out, as stated here. When the dock rises and falls, the copper wire will pass over the magnet, thereby generating electricity, and the wire will run from the generator to a rechargeable battery mounted on the dock. The battery will store the electricity to power the LED on the dock.
Hi, I'm Sebastian. I'm also a member of the technical team. From Paul, Lucille, and other sources, we have gathered multiple test equipment. One of them is called the Pickaxe microcontroller. You can think of a microcontroller as a tiny computer that can fit in the palm of your hand, and it can be programmed to collect data such as voltage and current, but also be used to control the lights that they only turn on at night.
Hi, I'm Christopher. I'm also a member of the technical team, and what I've been doing is I've been using a digital oscilloscope to measure the power output of our linear generator and take quantitative data about its amplitude and its efficiency.
For the past 6 months, several of us, including myself, have been working on the wave tank. The wave tank was originally constructed out of wooden plexiglass. However, this leaked. To solve this problem, we relined the wave tank with plexiglass and sealant. This has done an excellent job of fixing our leaks, and we will continue to improve it. You will see the wave tank in a demonstration this evening.
Hi again. Using the test equipment and information given to us by Paul Lucille, I was able to run an analysis of the linear coil at approximately 17 cycles per minute, because that is approximately the speed that waves cycle through. Measuring the average voltage using the oscilloscope at 21 millivolts and measuring the resistance of a rectifier with a voltmeter at 314 ohms, I calculated using Ohm's law the current after the rectifier, and it is 0.066 milliamps. Using all the information I've collected, I used the voltage and the current to calculate the power, which I got 0.001386 milliwatts, which is a very small power. We need 3.45 milliwatts to light one tiny LED. From this, I concluded that our system with the linear coil will never work.
I'm Walter Wilson, and I'll be talking about one thing that we've learned. The first thing we learned is that linear motion doesn't work at all really on this scale. So we're going to switch to rotary.
I'm James Bryan, and another thing we've learned is that the lake bed anchoring that we originally thought of is very problematic due to the changing water levels throughout the seasons on the lake.
The first major revision we have to our project is switching to rotary motion because, like I said before, linear motion doesn't work on a scale this large. We'll be doing this by attaching a servo motor to the dock with a pole extending horizontally towards the water that will be attached to another pole that will be anchored vertically in the water using an anchoring system that we're currently developing.
The anchoring system is basically a set of dampening plates on the bottom pole that theoretically will keep the pole from, the entire system from floating up to the surface or sinking too low due to the surface tension on the discs.
Our plans for the future will be to develop a working prototype of the generator generating enough power to light an LED and collect our data with the pickaxe. We'd also like to finish work with the pickaxe for the aforementioned data collection, and we'd also like to, in the far future, present at the Lemelson MIT Eureka Fest.
Hello, I'm Corinne Piper, and I am a member of the financial team. To begin with, we were awarded a $7,600 grant. Currently, we have spent $3,484.64, which means that we have $4,115.36 remaining. Through some calculations, we have discovered that we have spent about 45.85% of our grant. We plan to spend the rest of the money by the end of the process.
Hello, I'm Kristen Deniston. I'm from the communications team, and we have created a Facebook blog and a Twitter for to let the community know glimpses of our progress. And on the screen is the blog, and this is the Twitter, and this is our Facebook.
Hello again. At this time, I would like to express some thank yous from the team to some of our helpers. We would like to thank PPL Empowering Educators Grant for awarding us $2,000 to help us with our funding and to travel to Eureka Fest in late June. We would also like to thank our resource mentors from PPL and Paul Fusil, who will help us along with this process. And lastly, of course, we would like to thank our parents for their continued support of our project. Thank you for coming out tonight and supporting us.
Oh my gosh, oh, it worked. I think one of you should go and touch the water. You both so nice.
There, sliding consistently now. I think the serial plug had something to do with it. So we have that